Hey everybody, just time for me to do another video and try and catch you guys up with what I've been doing. Unfortunately, I don't have any personal work done, just some school work, and I figured I'd show that off. First one we have is a game called Reversi or Othello, and the idea was to create an AI that is pitted against the school's AI, and you're typically supposed to beat how well their AI does against their own. You're supposed to do better than that. It's kind of hard to explain. So you don't necessarily have to win black v white. You're always the black player, but you do have to make a better score than their own AI would have made against, again, their own AI. So, like, this is my advanced versus their advanced. So my advanced is supposed to win by just a small amount, but it actually wins by quite a lot. I think it's this one. My advanced versus their beginner version does way better. Yeah, my advanced versus their intermediate takes almost the entire board, which I thought was pretty good. So there's that. Not much to it. The interface was already set up for us. All we had to do was basically implement just the AI portion and say make this move in the end. I didn't have to actually make this actual window and all the gameplay and everything like that, all the basics you would have for this game to work. All I had to do was implement an AI function and like a couple helper functions I added. Anyway, so there's that. Then one of the other things we did in this same class was called, let me get this code out of here, called steering behaviors, and we basically have just a flock of ships, or this could represent pretty much anything, any sort of AI. And so I say I turn up alignment now, I want them all to go the same way, or I turn that back down and they're just going to sort of kind of keep going the same way because they have a little bit in alignment. But if I turn up cohesion, where they all want to be in the same, they basically want to be in the same spot, but they have a little bit towards alignment, they have a little bit towards separation. But turn all that down, they basically just want to all be in the same spot at the same time, but it's constantly an average of all their locations, so it's constantly changing as exactly what spot that is. So turn that back down. Let's just do separation, and let's also turn up alignment. So they all want to go the same direction, but they want to be very far apart from each other, or at least, you know, this value apart. So, and we'll turn down cohesion all the way. All they want is separation. They don't want to be in the same spot. They want to be completely separated. That sort of thing. That's pretty much it. So, it's kind of completely conflicting sets here. Add another task force, and I change that task force's alignment, and so it's pretty neat. Oh, my implementation is the same as their implementation. And then the last interesting thing we did was somewhere around here. I did my path planner. Is this even the good one? No, it's not. Best minimal search. I think this is my good one. I made a lot of versions of my path planner. I found a way to implement the C++ AMP for a breadth first search for the path planner. Anything more advanced, though, you have to suddenly, you can't have, I couldn't find a way to add any sort of multi-threaded or parallelism to it. But same deal, we were already given a sort of interface, but we had to really create the entire path search algorithm and ourselves, and however we wanted to implement it. Mine, for instance, doesn't have edges. You're supposed to create a bunch of edges for all of your planner nodes, and I don't know. I didn't even know how it was supposed to work. All I know is my I tried to use in the end I ended up with probably about as minimal memory usage as you can get, and very, very fast run times. Most of my run times were better than the run times that the school had implemented, because you have you don't have any code for it. You just have an example AI to run against for timing, and it's usually it took like a tenth of a second. This is in debug mode, so I go to release and Control F5. I have to rebuild it in release. I'm really worried about showing off my code here. I can't. Nobody could even use it. It's so. I don't want to sound too full of myself, but so unique because I didn't follow the directions or really didn't have any idea what we were supposed to do as far as coding, as like edges. I don't know what those were supposed to be or even represent. I just sort of took the general assignment and ran with it and came up with my own unique implementation for making a star. So now we're down to, instead of 0.01 or 0.1 seconds for timing, we're at 0.001 seconds. So 1/1000th of a second to, or just over 1.5 1,000ths of a second, let's say, to path from here to here. I wish I had left in the implementation, the part of the implementation that colored all of the squares and showed you all of the squares I checked to get to this result. But, oh well. Maybe next time, if anybody requests it, I can definitely put it up here. I doubt anybody will, though, but feel free. The last thing I had was Ms. Pac-Man. There we go. Man, I wish I could make that bigger. So my Ms. Pac-Man, same deal. This is already set up, except the AI would just make Ms. Pac-Man sort of gyrate back and forth. And then you write over whatever's making her even do that. I forgot what the deal was. A couple lines of code. And implement your own AI to try and get a high score. The score you were trying to beat, I want to say, was 4714. And yeah, so I went for the Occam's razor on this because we're pretty much told to, like, hey, just try and make it fairly simple and you'll probably do better than if you tried to do something cool. So yeah, you see there, I don't even really have good ghost avoidance. But my average score was, if you see here in the bottom left-hand corner, 8477. So I was blowing away it was 6414 was the score to beat. So I was like, 2,000 above the score I was trying to beat. So I got like 103 or something, or 102 on this assignment. And I just kind of went with that and moved on to the next project, unfortunately. But I'd like to come back to this sometime, and it'd be interesting to try and beat or make an AI that can beat the game. When they run the test as well, you see my score is actually quite a bit lower than the average, which really shouldn't be that much lower than the average, and it'll do this almost every time. Even though the ghosts have a sort of just a bit of randomness in their AI, they'll just randomly turn around and change their direction. Yeah, so there's that. But yeah, there's two other levels. I just don't know where the code is, basically, to change which levels you're testing your AI on. I just went for sort of the visual confirmation that Ms. Pac-Man was doing what I wanted her to do. Hang out by a power pill, and oops, didn't mean to do that. Didn't mean to do that either. I meant to do this one. So yeah, so she'll find out where the nearest power pill is. Sit 1 pixel away from it until a ghost is very close to her, like basically just about to hit her or the power pill. And then I eat the power pill. And then I hang out by a power pill again until a ghost is within 1 unit of me, of Ms. Pac-Man, and I go eat as many ghosts as I can without any ghost avoidance, and that worked out pretty well for me. So that's all I was going for. Just trying to get a good grade, and then I can move on to robocode, which I did horribly at. Unfortunately, I just could not get a satisfactory AI going. for that particular assignment, but still ended up knocking the crap out of the class with all the extra effort I put into the other assignments, so not too bad. So we got a score of 8670 that time. And yeah, you can see if I just put in a little more ghost avoidance, yeah, life would be dandy. So that's pretty much it. I'll catch you guys next time. I'm trying to have some actual more personal stuff done.